Good morning, afternoon, or evening. How y'all doing today? Welcome back to Miss Morrow's Algebra 2 class. Today we're going to be talking about relations and functions. Very important for you guys to understand these definitions, not just see them and write them down. I need you to learn them, okay? The first thing we're going to talk about is a relation. And a relation is any set of ordered pairs. Please remember that an ordered pair is made up of an x, or input value, and a y, or output value. X is the input because it's independent. It could be anything it wants. Y is the output because it is the answer when an X is given. So, for example, let's say you go to the movies, okay? Now let's just say for whatever, it's $5 a movie. I can choose to buy 0 tickets, or I can choose to buy 10 tickets. That would be my input because it's my choice. It's independent. If I buy 0 tickets, my output is 0. I paid nothing. If I buy 5 tickets, my output is $25. Okay, so input is X, output is Y. Input is the independent variable. Output is the dependent variable. There are 4 ways to write relations. The first way is by simply listing out ordered pairs. So for example, in this case, we have 1, 8, 1, 4, 2, 9, and 3, 2. We can transfer those points into what's called a mapping diagram. And in a mapping diagram, gentlemen, you have an input and an output. The input, of course, are the X values. The output, of course, are the Y values. Please notice, though, that when making a mapping diagram, if you have repeating inputs or outputs, you only have to put one of those in the mapping diagram. Why do you have to only put one of them? Because it is a mapping diagram. So the mapping diagram tells you what that in particular input value translates to as the output. So in this particular case, the input value of 1 renders an output of 8 and an output of 4. In this particular example, the input of 2 renders or gives you the output of 9. In this particular example, the input of 3 renders or gives you an output of 2. Does that make sense, guys? Thank you. May I continue? Thank you. You can also make a table of values. And in a table of values, gentlemen, you're literally going to make a table. Literally an X and Y table. X, remember, is the input, always. And please remember that Y is the output, always. When you're making a table, all of the values must be there. It's not like a mapping diagram where you don't have to show the repeating inputs or outputs. All of them must be there. And last but not least is a graph. So let's go ahead and show you how to graph these points. 1, 8 would be right here. That's 1, 8. When the X is 1, the 8 is Y. 2, 9 is right up here. When the X is 2, the Y is 9. 3, 2 is right here. When the X is 3, the Y is 2. And 1, 4, when X is 1, the Y is 1, 2, 3, 4, right there. So you have to be able to toggle between any one of these 4. If I give you the relation in a graph, you better be able to put into a table, into a list of ordered pairs, and into a mapping diagram. If I give you a mapping diagram, you better be able to put it into a table, a list of ordered pairs, and a graph. Does that make sense? Okay. Okay. Domain and range. Domain and range are 2 huge topics that confuse a lot of people. Today, we're going to end all of those confusions. The domain, guys, the domain is simply a fancy way of writing the X value, which is also called the input, which is also called the independent variable. It's just a fancy way. When they're talking about domain, we're talking about all possible x values, which are also the input values, which are also the independent variables. When we're talking about range, range is a fancy way of writing the y values, which are also known as the dependent, and it depends, believe it or not, on the x, the dependent variable, or the output. And it's the output, again, because it is the answer to whatever function you're plugging it into when you have a particular x. Okay? So how do we find domain and range from graphs? Well, since domain is the x values, the possible x values, we're talking about a horizontal shift. Think about the horizon when you go to the beach for horizontal. Trust me, that helps. If you remember horizon, it's horizontal. It'll help you forever. So I want to know from left to right, what are the possible x values here? Well, this is -3 and this is 5. Every single one of these x values corresponds to a point on this graph. So therefore, my domain is every x that is greater than or equal to -3, but less than or equal to 5. Please be honest, guys. Please. Does that make sense? Sir? A decimal? No, there are decimals within -3 and 5. There's fractions, mixed numbers, repeating decimals, rational numbers, irrational numbers. Every single value between -3 and 5 corresponds to a point here on the graph. Yes, sir, my brother. Thank you.
So if the dot is in between two lines,
I'm not trying to be rude, but what do you mean with the dot?
the points.
Okay, I have no idea what you're asking.
The two endpoints.
Okay, the two endpoints, yeah.
If
It's between -3 and 5. Everything here in between is the domain, my brother.
it's not on exactly like the line. If it's in between,
Oh, what you're saying is if it's not an exact point and it's there, I'm not going to make you estimate that. You'll have exact points. It's impossible for me to tell you what that point is right there. Is that -4.5? Is it -4.3? If I did it like that, I would tell you what that x value was. Is that what you're asking? Thank you, my brother. God bless you. Okay. Now, the range. The range is the vertical values, the up and down values. So I look at my lowest value here. I look at my highest value there. Every single y value here corresponds to a y value on this graph. Do you see this? So the range here will be every single y value greater than or equal to 2, but less than or equal to 1, 2, 3, 4, 5. Does that make sense? All right, let's see. Let's see how much sense it makes. Let's find the domain for this bad boy here. The domain here, what is the furthest point to the left that you have here? That's right. 0. But doesn't it continue going this way forever and ever and ever? So what would my domain be? Not positive infinity, but from 0 to positive infinity. Yes. And you know what? I should have, to be honest with you, I should have written this in interval notation. This would be between -3 and 5. And this would be between 2 and 5. I am going to ask for it in interval notation. You guys can handle it. I know you can. Yes, sir. Well, if I ask for the domain and range, yes, you would put both the domain and range.
no, I mean like interval notation.
Now, I will ask you either interval notation or I will tell you set builder. Thank you. But I'm telling you right now, do it in interval notation. Please and thank you, my brother. God bless you. Okay, how about the range? Okay, here's a tricky one. You got it? I love you. Wow, you guys are so awesome. Look, guys, do you see how this is steadily, slowly, but steadily going down, 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 down? It's going to keep going down to negative infinity, isn't it? And do you see how very slightly, but little by little, it's going up, 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 up? Do you see that? So it's going up to positive infinity as well. So in this particular case, my range is from negative infinity to positive infinity. Every single y value is valid here. But the only valid x values are between 0 and positive infinity. So, my brother.
I don't understand, like, why domain is 0 then?
Okay. Am I going, what is the furthest to the left?
Oh,
I'm not going on this side of 0, am I? No. I'm going to the right of 0, but I'm at 0 as well. Thank you so much for your honesty, son. Does that make sense, gentlemen?
yes.
Promise.
Yes.
Okay. Okay, I gave you an input and output table here. I want you to tell me the domain and the range. What's the domain here, guys? Hint, hint. What's another name for domain? Input. So what's the input here? 36, 25, 42, and 41. Those are the possible x values for this particular relation. What's the range here, brothers? Remember, the range is a fancy name for the output for the y value. So what's the range here? 8.08, $8.08, yeah. $10.57 and $11.82. This is different than a graph because there's no numbers in between. These are particular values that they're giving you. How about, for example, number 4? What's the domain here, my brothers? Which, remember, domain is just a fancy word for the blank values. Come on, the blank values. X values. Very good. So what do we got here, my brothers? 5, -1, -4, and 0. Oh, yeah. What is the range? Please remember that the range is just a fancy name for the blank values, for the y values. Good. So what's my range here, my brothers? 3, 4, 9, and -5. Giddy up. Does that make sense, my brothers? Be honest. You've seen this before, right? Has it ever made sense like this? That's because you're a boss. All right. We're good? Promise? Don't mess with me. All right. What's the domain here, my brothers? -3, 0, 2, 9, 23. I am so freaking proud of you. Good job, guys. What's the range here, my brothers? 14, 7, 0, -18. Heck yeah. Great job, boys. Great job. Nice and easy. But it's not so easy when you don't know what the domain is. It's not so easy when you don't know the range is. That's why I want to really make sure you guys got this down pat. Does that make sense? Promise? May I continue? Thank you. All right, boys, let's see who's really paying attention here. What's the domain here, guys? Uh-oh. Yes, sir, domain. Okay, no, you're starting off wrong. 7 is not even remotely close to the domain. Okay, yes, sir. Very proud of you. Guys, domain goes from left to right, guys. So this is 1, 2, 3, 4, 5, 6, 7. And this is 1. He just got the placement wrong, but he knew what he was talking about. So x must be greater than or equal to -7, but less than or equal to 1, which is -7, comma 1 in interval notation. Yes, sir. -1. My bad. Thank you, gentlemen. Excellent. What is the range here, guys? Remember, the range goes from bottom to top. What's the range here? This point here is 1. This is 1, 2, 3, 4, 5, 6, 7. What's the range? What is it? It's greater than or equal to 1 and less than or equal to 7. 7, my brothers. Which in interval notation It's between 1 and 7. Guys, I don't see you as excited as before. Do you not? Did I not make it clear how to find domain and range? If I did a bad job, you need to tell me right now, this second. It's hard to see. That's why I tell you to print out your notes. That's why I also tell you you could do it on your iPads. Yes, sir. Well, my brother, if I'm between negative 7 and 1, x is greater than negative 7, but less than 1. It's in between. For the range, it's between 1 and 7. That means it's greater than 1, but less than 7. I thank you. Does that make sense, my brother? Are you sure? Now's the time to ask, guys. There's no shame here. Okay, I believe you. What's the domain here?
X is greater than or equal to negative.
Nope. Nope. Yes, sir. That's right. To positive infinity. Good job. Why? Guys, isn't this continuing to go to the left little by little? Isn't this continuing to go to the right little by little? So that means it's going to hit eventually all the x values on both from negative infinity to positive infinity. How about the range? What would the range be here? What's the lowest point of this graph? Right here, which is at negative 1, 2, 3, negative 4. What's the highest point of this graph? You do know. Isn't it? No, this is not the highest point of this graph. It keeps going on forever, guys. Aren't these arrows moving up forever? So I'm going from negative 4 to positive infinity. Yes, sir. If one of those arrows were to aim down, then I'd be going from negative infinity to positive infinity for the range as well. What he asked was this, gentlemen. If I have a graph like this, now in this case, both domain would be negative infinity to positive infinity, because I'm going little by little to the left forever, little by little to the right forever, and my range would be negative infinity to positive infinity, because I'm going little by little down forever, and I'm going little by little up forever. Yes, sir? Okay, good question. If I had an equation like this, okay, it is an undefined slope, but what's the domain here? What's the only valid x? Let's say this was at 5. What's the only valid x value? So x would equal 5, that's it. But what's my range here? It's going from negative infinity to positive infinity. Whoever said 0, please rewatch this video. Okay? Or come see me in the morning, because you don't get it. Yes, sir. If it's just one number, you just put 5. Thank you, my brother. Great questions. Anything else, my brothers? You're doing great, guys. I'm proud of you. I love the honesty. May I continue? Thank you, gentlemen. Okay, now, a function. A function is any relation. So, hint, hint. Any relation, awesome. We already know the 4 ways to write relations, right? We know how to find the domain and range of any relation, right? Well, guess what? We already know the 4 ways to write a function, and we know the ways to write the domain and range of any function. A function is a relation. However, it's a relation where each element of the domain corresponds exactly to one element of the range. In other words, remember this. A function is a relation where there can only be one y value for any given x value. So when I have a value of x and it gives me an output, I can only have that same output forever. I cannot have different y values for the same x value. I cannot have different y values for the same x value. I cannot have different y values for the same x value. I can have different x values for the same y, but I cannot have different y values for the same x value. Let me explain what I mean. Determine whether or not each of these is a function. 1, 8, 2, 9, 1, 3, 2, 1, 4. Do I have two different y's for the same x? So this is not a function. How about number 2, or B? 1, 8, 2, 8, 3, 8, 1, 8. This is a function, yes. Look, when x is 1, isn't y 8? When x is 1, isn't y 8? Now you may be saying, but Mr. Morrow, all the y values are the same. That can happen. Because what this ends up being, and we're going to get into this later, that's a horizontal line. That's a y equals equation, which is a function. However, let's look at C. 1, 8, 1, 9, 1, 2, 1, 4. This is not a function. I cannot have different y's for the same x value. I cannot have different y's for the same x value. How about D? 1, 3, 2, 5, 3, 7, 4, 9. Yes, function. How about letter E? 1, 5, 1, 9, 3, 2, 4, 8. No, I cannot have different y's for the same x value. So this is not a function. How about F? Why is it not a function, my brother? Beautiful, because I have 4, -1 and 4, 1. I cannot have different y's for the same x value. And what about G? That is a function, because every x value gives you one particular y value. Gentlemen, does that make sense so far? I am sure that G is a function. -7, 14, 9, -7, 14, 7, 7, 14. Where do you have the same x giving you different outputs? Does that make sense, my brother? That's okay. Thank you for caring. Last but not least, if I give you a graph, I can determine whether or not it's a function by using the vertical line test. Okay? Vertical line test simply works like this. I literally draw a vertical line through the graph. Guys, how many times does this vertical line hit the graph? And here? And here? That means that every x has one y value. Give me 1 second. If I do a vertical line here, though, at this particular x, how many y's do I hit? Can I have two different y's for the same x? So this is a function, yes. This is not a function. If I do the vertical line test here, at this particular x value, how many y values do I hit? Can I have two different y values for the same x? So this is a big fat no. How about here? When I do a vertical line test, how many y values do I hit at this particular x? Can I have two different y values for the same x value? No. Guys, thank you very much. Have a great day, and I hope you learned a lot. Homework is valid.